Good morning. We'll start our official agenda in a moment, but first I'd like to show you a quick 3D fly-through of a model made with the Warehouse and Logistics Library. This will give you an idea of how realistic your warehouse models can be. This is Ray Chadwell. I added narration to this excerpt of a made-by-the-developer fly-through from a crane's eye view that's moving through a model built with the Warehousing and Logistics Library. This gives you an idea of how realistic your warehouse models can be. Okay, we are going to start with an overview of PMC and warehousing, then briefly cover modeling warehouses with standard plant simulation objects, then on to rapid modeling with the Warehousing and Logistics Library, and finally we'll wrap it all up. The warehouse business has several potential pain points, previously known as problems, some universal to most businesses and some unique to the industry. Our first warehousing and logistics pain point is the sad fact that customer contracts are getting shorter. Next is a large customer base with a large product mix. Also, product mix is changing all the time. It's difficult to convince new potential customers during negotiations if they can't visualize the process. Seasonal influences, no insight of operational costs versus operational activity, changing strategic expansion plans, warehouse management system implementation, customization, make versus buy, for example, new construction versus refurbishing existing warehouse, and last but not least, invest in automation or expand conventional warehouses. The solutions to all these problems has two key ingredients. First, Technomatic's plant simulation provides a powerful, full-featured discrete event simulation suite of modeling objects and tools. This slide shows the average return on investment experienced by 600 plant simulation users in a wide variety of industries who perform traditional discrete event simulation analysis and optimizations. Results include a 12-to-1 average value cost ratio. I've witnessed this kind of return on investment in the projects that I've been involved in. While plant simulation provides a powerful engine to build, analyze, and optimize your processes, the Warehouse and Logistics Library provides the second part of our solution. It turbocharges that engine by providing objects and tools that slash the time required to build, analyze, and optimize your warehouse simulation models, and provides a high level of detail and visual realism. You could see that in the brief demo video. Our next topic is a brief discussion about modeling warehouses with standard plant simulation objects. In days of old, when computers were a lot slower with a lot less memory, warehouses were often modeled as a black box. The black box was just one buffer object like you see in the middle of this frame. An overall average pick place time may have been or used, or if you were fancy, you'd have separate average pick and place times. This had the advantage of being fast, but it assumes that average pick place times are, quote, close enough. There are never any forklift traffic jams that create delays, and that you are never starved for forklifts, never have to wait for one. If any of those assumptions were not correct, then the model could be very inaccurate, not to mention having poor visualization. To improve accuracy a bit, part-specific pick place times could be stored in a table and used in the simulation. Since computers were slow, a trick was often used to speed things up even more. Instead of explicitly placing moving units or parts in a storage object like a buffer, parts would be deleted and a number in stock entry was incremented in a table, a spreadsheet object. Conversely, when parts were picked up, the number in stock entry was decremented in a table and parts would be recreated. This has the advantage of being extremely fast, but has the disadvantages mentioned before. However, if this is close enough accuracy, it's quick to model and avoids potential number of parts limitations. So what can you do if average pick place times are not close enough? If there are forklift traffic jams and the number of forklifts is small, so you often have to wait for a forklift and people want to see forklifts moving around. If the number of storage locations is relatively small, or if you can just model areas of relatively small number of locations, you can model those locations with individual buffers and model forklift movements with tracks of appropriate lengths and forklifts set for real-world speeds. You see them there. It's called a transporter, which is modeling a forklift. Simplifying by grouping numerous racks into areas may be close enough for your needs, but what if they aren't? You could model each individual rack as a buffer, but what if there are hundreds or thousands of racks? You could model that, but it'd be very time-consuming and tedious, and you still would have the third height dimension not modeled. To come closer to 3D realism, you could use PlantSim's high bay warehouse object instead of the buffer object. It does look nicer and can span distances by being scaled, but you have to do that by hand, and you are limited to specifying the number of shelves in the X and Y directions with no control over actual physical dimensions or details. This may be enough, but it's still time-consuming and tedious to model and position numerous racks and tracks. And what if the big cheese of your company wants realistic visualization, down to the details like varying shelf heights in one rack? And what if your head honcho wants a warehouse modeled and analyzed before the end of the week? Our next topic is rapid modeling with the warehousing and logistics library that can meet the demands just mentioned. The Warehousing and Logistics Library provides several high-level storage objects that provide detailed modeling of various storage objects commonly found in warehouses. The first high-level storage object is the SingleDeepRack. This rack is similar to the built-in high bay warehouse object we discussed earlier, but this rack is a lot more customizable. In the 2D view of your simulation, the SingleDeepRack looks like this. And the 3D representation looks like this. All rack objects can be quickly customized for the number of clusters or shelves across. Our example has 3 clusters. And the number of levels. Our example has 5 levels, and the depth. You can even specify individual lengths for each cluster. Our example has equal lengths. And individual heights for each level. Our example has double the height for the first 2 levels from the bottom up. As you can see, for 3D, you can also change shelf and column dimensions and colors. If you are a nerd like me, you may prefer to do everything in 2D, so you could care less about 3D. But if you need realistic 3D visualizations, these quick and powerful 3D options are invaluable and can save you a lot of time. The DoubleDeepRack is similar to the SingleDeepRack, but is also 2 shelves deep. Besides the same customization options as a SingleDeepRack, you can also easily restrict the storage to only the same part front and rear, or allow different parts, and you can choose to always fill the rear first or not. The pushback rack is designed for use with a deep reach fork truck. The flow rack is loaded at the back. Parts roll or flow to the front for picking. Besides the same customization options as the SingleDeepRack, you can also easily change the flow speed, flow angle, and change the pallets per lane, so you have full control over how that rack operates. The DriveInRack allows forklifts to drive directly into the lane of stacked rows. Besides the same customization options as the others, you can change the pallets per lane. Block stacking models inexpensive floor storage. You can switch reachability between 1 and 2 sides, set the height per pallet, set pallets per lane, and pallets per stack. There are several trucks that you can pick from to transport your parts inside and outside your warehouse. The truck object models a traditional on-the-road truck. This can be customized for length, speed, and capacity, and as you can see, it has a 2D object and a realistic 3D equivalent. ReachTruck forklifts can be customized for travel, lift and low speeds for loaded and unloaded conditions, reach and positioning speeds, and pallet pickup and put times for the dock and expedition areas. The high-capacity ReachTruck forklift can also be customized for pallet capacity. PalletTruck forklifts can be customized for travel speeds for loaded and unloaded conditions and pallet pickup and put times. The high-capacity PalletTruck forklift can also be customized for capacity. Additionally, all these objects can be customized for the numerous parameters in PlantSim's built-in transport object, including length and width, acceleration, and optional battery modeling and parameters. There are several other warehouse objects. Pallets are the moving units that get transported to, from, and stored in warehouses. They contain a variable number of articles or parts. The pallet can be customized for length, width, height, maximum volume, and maximum weight. Docks model the loading docks for trucks. They can be customized for width, height, truck connect and deconnect times, pallet pickup and put away times, usage as inbound only, outbound only, or both. The expedition area models the staging areas for the docks. It can be customized for length, width, pallet pickup and place times, and maximum utilization. Aisles model the aisles that warehouse trucks move on. They use PlantSim's built-in 2-lane tracks and can be customized for length, width, capacity, etc. An automated storage and retrieval system can also be modeled with the ASRS objects. The warehouse is the top-level object for a warehouse. It can contain any of the objects that we've covered so far. It lets you customize the overall width, depth, and height of your warehouse, one or more storage areas that can be quickly configured for a given amount of aisles and racks, oriented left to right or top to bottom. You see top to bottom orientation in the examples here. One or more groups of docks that can be quickly configured, one or more expedition areas that can be quickly configured, and one or more trucks that will be used inside the warehouse, and several operation options like storage strategies. The top-level objects appear in a frame or window, one level up from warehouses. The warehouse project provides the top-level frame or window for your project. It automatically provides a starting point that includes a warehouse manager. One site is automatically created. You are prompted to enter a site name. For example, a town in Michigan with a massive population of about 266 people. Projects can contain more than one site, so you can easily include all your sites in one model. One warehouse is automatically included in the site. Note, a site can contain more than one warehouse. And an event controller is automatically created. In case you are not familiar with plant simulation, the event controller is the simulation clock that includes stop-start buttons, speed adjustments, etc. Sites can contain one or more warehouses. Sites can be customized for the external transportation object that models deliveries to and from the site, internal truck creation based on a delivery table or on-demand specification, and inbound and outbound yard management strategies like random, cyclic, minimum expedition, customer-based, or custom build. The warehouse manager is the overseer of your warehouse model. It lets you add or delete sites, add or delete warehouses for a given site, open a site, and open a warehouse. Set order flow options like order activities and back orders, add, delete activities. Set inventory options like whether to create a start inventory, import or set master product data, and start inventory. And you can create a 3D frame for sites and warehouses, so you always have the option of visualizing your warehouse in both 2D and 3D. The supplier models the delivery of articles to a warehouse. It lets you specify the transportation object that we'll discuss in a moment, the working mode options like external orders, historical data, or random output. Truck handling options like time per truck, time per pallet, and capacity. Order handling options like time per order and capacity. And data management options like inventory data and historical data. The consumer models the place where articles from the warehouse are delivered. In plant simulation terms, this serves as the drain for the model. It lets you specify the working mode like random orders, no order generation, or historical orders, number of orders per year, lines per order, items per line, and truck handling. Data management options like historical and inventory data and open purchasing orders are also available. The transportation object manages the supply chain's trucks that travel between sites. It lets you specify the number and capacity of each type of truck. The number of routes and the destinations for each route can be specified. And now, it's demo time. You'll see how a model can be rapidly built with the warehousing and logistics model and how the model looks in both 2D and 3D. For those of you who are not familiar with plant simulation, the class library contains all the modeling objects and tools divided into Windows-like folders. The first 7 folders contain PlantSim's standard built-in objects that can be dragged and dropped into a simulation model which is contained in a frame. For example, the material flow folder contains numerous objects like assembly that models an assembly station and pick and place that models a pick and place robot. The toolbox organizes the same objects into toolbars that also provide convenient access to those objects. From here you can drag objects as in the class library, or click in the toolbox, then click in the frame as I'm doing now. I'm turning off the material flow folder and the toolbox to provide us with more screen space for our demo. The warehouse library folder contains numerous high and low level objects that add rapid, realistic warehouse modeling and advanced analysis capabilities to PlantSim's standard capabilities. Warehouse Project provides the top-level frame or window for your project. It also provides a jump start to your project by automatically creating a few items. The first step is to create a duplicate of this object and put it into a folder like the Models folder. To do that, you just hold the Control key down and drag the object to the Models folder. As you can see, you are automatically prompted to enter a name for your project, which we'll call Demo. Then you can enter the name of the site, which we'll creatively call Site. Note, you can add multiple sites to your project later on. And finally, you enter the name of the warehouse, which we'll innovatively call Warehouse. Note, you can add multiple warehouses to any site later on too. This flexibility allows you to model anything from one site with one warehouse to a global operation with sites with multiple warehouses. As you can see, our smart and helpful warehouse project object gave us a jump start by automatically providing a frame or window for our model to reside in, along with a few key items instead of making us do it manually. You may recall that the warehouse manager is the overseer of our warehouse model. The event controller is Plant Simulation's clock that controls the running of your simulation. It includes start-stop buttons, speed adjustments, etc. The site models the location of our warehouse. A right click of the mouse shows that our warehouse was also automatically created inside the site. Finally, the name of the frame for our model was changed from Warehouse Project to Demo. Now we can get to the fun part. One way to open up our warehouse's dialog is to right-click on the site and select any warehouse that's in it. Our first step is to define the dimensions of our warehouse floor in the Dimension tab. We'll set it up to be 45 meters wide and 40 meters deep. We'll keep the default for height at 8 meters. Now we click the Apply button. Let's click on the 2D model button to see the 2D view of our warehouse. We've only built an empty 1,800 square meter building. The perimeter of our warehouse is defined by the red rectangle that you see now. A warehouse without a storage area is like this library without PlantSim. So let's create one. To do that, we click on the Storage Area tab. Now we click the Create button. Let's name it Area 51. We want to start our storage area at the upper left corner so we can leave the default values for the distance parameters. Let's set the number of aisles to 10, the length to 27, the width to 1.9, and one aisle across the top. Finally, we'd like our aisles to flow from top to bottom instead of the left to right default. We have one more tab to fill out for Area 51, the Storage tab. We'd like to have storage sides on both the left and right sides of an aisle. We're going to be using SingleDeepRacks. We're going to use the default SingleDeepRack, which we can drag and drop from the class library. It has 3 clusters or shelves across, and it's 5 shelves high. Alternatively, we could have used our own customized SingleDeepRack. Finally, we click OK twice. Here's our storage area, all nice and neat. The storage racks in white, the aisles in between them in gray, and the aisles across the top that we wanted, along with all the behind-the-scenes aisle sensors and control logic necessary to model the movement of your forklift trucks. If you've ever laid something like this out by hand, you'll know what a massive time saver that this library can be. Now it's time to create our loading docks. The Open Dialog command from the Warehouse Library pull-down menu provides a quick way to get back to the Warehouse dialog. We can probably add some docks in that tab named Docks. Click New Group to make a new group of docks. We want 6 docks. We want the docks at the bottom, in other words, down instead of up. We can drag the class of docks that we want from the class library. We want the first dock's midpoint to be at 4 meters. And we want the in-between distance for all the docks to be 6 meters. The Warehouse and Logistics Library performs more magic by rapidly creating your docks, whose 2D view appears as red rectangles. We have one more major warehouse area to model, the Expedition or Staging area. You guessed it, click on the Expedition tab in the Warehouse dialog. Click Create New. Drag the Expedition class into the class parameter. Now let's connect the Expedition area with the docks by clicking Select and selecting them. Then we connect the Expedition area with the Storage area by clicking Select and selecting the aisles. Finally, we enter 1.9 meters for the width. So we're done with all the major areas in 9 minutes. Pretty cool. Notice that besides the automatic creation of the Expedition area, the Expedition aisle was also created. If you scroll down a bit, you can see that truck entry and exit points, along with connector lines to and from the docks, were automatically created when we specified the docks. The model includes 2 tracks that serve as the home base for the 2 forklift trucks that are specified in the Resources tab of the Warehouse dialog. At the top level of our hierarchical model, inside our project frame, supplier, consumer, and transportation objects and tracks were added to send trucks from the supplier to the warehouse docks and from the warehouse docks to the consumer. Back to our warehouse. Immediately after starting the simulation, you can see the 4 pallet trucks and 3 reach trucks sitting at their home base tracks. Now let's run the 2D model slow enough to see details. Right after clicking on the Event Controller Start button, the racks are loaded up with the initial contents based on user input. The simulation clock remains at 0 until initialization is complete. Empty shelves are white, full shelves are blue, and partially full shelves are half white, half blue. You can see pallets being delivered to and from the racks, to and from the expedition area, and occasionally being loaded from or loaded to trucks that come in from the top level frame where the warehouse manager, site, supplier, and consumer objects reside. To see the 3D view of our model, select the Open 3D option from the Warehouse pull-down menu. As you can see, we can rotate, pan, and scale the model. We're running the clock fast to show that performance is quite good, especially since we are watching both the 3D and 2D views running simultaneously. That's all for now. Thanks for watching. Okay, our next topic is wrap-up. As you probably know, discrete event simulation tools like PlantSim let you analyze your facility, including locating bottlenecks and playing what-if games to optimize it. Since the warehousing and logistics library runs under PlantSim, you have the full suite of PlantSim's powerful analysis tools available, including the Sankey diagram, where flow is indicated by the thickness of lines, bottleneck analyzer, charts, and experiment manager. You can also have objects like variables to display data on screen and checkboxes that can be set up to allow quick what-ifs like turning shifts or downtime modeling on and off. The Warehousing and Logistics Library's Hotspot Analyzer is a very nice color-coded visualization of the amount of traffic on aisles, where blue is low traffic and red is high. This can help you to pinpoint areas to focus your what-if games, like changing traffic flows or where articles are stored. Like all of PlantSim's built-in modeling objects, the Warehousing and Logistics Library objects have statistics tabs that provide useful overview and detailed results data. The Warehouse Manager Statistics tab shows orders placed, orders received, and back orders. The Orders In button shows detailed daily statistics of orders for all days that were simulated. So depending on what level of detail you need, you can really drill down and get very detailed statistics. The site statistics include truck plot graph, a truck histogram, and detailed truck log. The supplier statistics include number of orders, number of pallets, and number of trucks. The consumer statistics similarly contain number of articles, number of orders, number of trucks, and number of pallets. Rack statistics include current contents, total entries, total exit, relative occupation, and detailed statistics options. Aisle statistics include all the statistics provided with PlantSim's built-in track statistics, and also including working percentage, waiting percentage, relative occupation, maximum contents, total entries, etc. The expedition area statistics include current contents, total entries, total exits, relative occupation, a histogram, area usage charts, and detailed statistics for this instance and for the entire class, which would show overall statistics for all the expedition areas. Dock statistics include average loading and unloading times, total number inbound and outbound, total pallets in and out, dock occupation, detailed inbound-outbound statistics, and a utilization chart. The benefits of using the Warehousing and Logistics Library include reduce modeling time of warehouse and logistics operations, often by more than 90%. You can build warehouse models in minutes or hours instead of days. No programming knowledge required, but of course you can still customize things with PlantSim's built-in objects, including methods that contain custom programming. As you've seen, PlantSim and the library include extensive what-if analysis options. The library also provides a high level of accuracy and realism. You've already seen how detailed and configurable objects like the racks are. Finally, the detailed 2D and 3D visualizations provide a powerful communications tool. Potential results of simulating your warehousing and logistics operations include investment savings from 5 to 25%, operational savings from 10 to 20%, productivity increase up to 20%, traffic congestion decrease up to 25%, activity throughput time decrease between 10 to 80%. Finally, by balancing the whole system instead of local optimization, productivity can increase 10%.